So in this case, we are going to consider our questions under our exponents. So the first part that we are given, it was to simplify on 2.1. So that is, we are given to simplify this whole exponent for 4 marks. All right, let's try to figure out how can we simplify this. All right, that's 2.1. I'm just gonna try and rewrite our expression here so that at least you can see it properly. So we were given 3 times 2 to the exponent of x plus 1 minus 2 times 4 to the exponent of x, 3 times 2 to the exponent of x, minus 2 to the exponent of 2x. So this is what we are given. And from there, you are being asked to simplify. Remember, our factorization is we had that we are supposed to factor out the common term. What is common? What is it that we have? So in terms of 2 to the exponent of x, we can actually see that there is a potential of this 2 to the exponent of x. Even in 4 there, we can have it. So let's try to work out the 4 first so that we can figure out how to factorize this. So this is x plus 1 minus 2. Remember, 4 in the base of 2 is 2 to the exponent of 2. But already there is what? X. So it will be 2 to the exponent of 2x. 2 to the exponent of 2 raised to the exponent of x. We simply multiply exponent. So it will be 2x. So this is what we have there. 3 times 2 to the exponent of x minus 2 to the exponent of 2x. So we need to factorize there. What is it that we need to factor out? In terms of the 2 to the exponent of x, let's start with that one. It can be easier. It is not the only part that we have, but let's figure out that one first. 2 to the exponent of x. I said when you are given addition and subtraction, do not worry about that. X, maybe you're given 2 to the exponent of x plus 1. When you factor out 2 to the exponent of x, you remain with what? What is remaining? 2 to the exponent of a 1. If it was a negative, the same thing, it will be to the exponent of a negative 1. But what about this 2x? What does it mean? 2 to the exponent of 2x means the same thing as we can write it in different ways. This is a product of 2 to the exponent of x and 2 to the exponent of x. I don't know if we are together there. The product. Okay, let's get back to the product. If the bases are the same, how do you multiply? Let's say you're given this. Remember, you add the exponent. So it was going to be 2 to the exponent of x plus x. What is x plus x? This is 1. This is 1. 1 plus 1 is what? 2x. So be careful there. It's a product of 2 to the exponent of x and another 2 to the exponent of x. But I also explained this when you are working with an equation. Let's say you want to formulate a quadratic equation. The same 2 to the exponent of 2x, this one, can be written as 2 raised to the exponent of x and raised to the exponent of 2 like this. 2 to the exponent of x squared. Maybe you can understand that it means the same thing as this one. You're multiplying that. That means there are two of them. There are two of them. So for you to properly understand this factorization here, it is best that you write it this way. It means the same thing as this, but for you to understand your factorization, best to write it this way. If you are dealing with equations, best to write it with a squared. So meaning to say there, we can just try to have it this way. This is x plus 1 minus 2 times. We just want to separate this. So like I said, it simply means 2 to the exponent of x times 2 to the exponent of x, so that we can properly see when we are to factorize. The denominator, the same thing, 3 times 2 to the exponent of x minus 2 to the exponent of 2x means 2 to the exponent of x times 2 to the exponent of x. So meaning to say, in the numerator, we can factorize. We can factorize. Remember, to the exponent of x plus 1, this one means there's another 2. So let me just separate here so that we can understand each other, because there's another 2 that we have here. So this one, it was supposed to be written as 2 to the exponent of x times 2 to the exponent of 1. Take note there. It's addition. So remember, if you're multiplying, I'm going to add x plus 1, which is same as what? X plus 1. So remembering that, guys, a number raised to the exponent of 1 is just same as we can just write as 2 like that. So why writing this way? So that we can properly see that in the numerator, the terms that are common there is a 2 to the exponent of x here, a 2 to the exponent of x. We also have a number, this number 2, this one, just a number 2. Remember, these are different terms. We're talking about this as a term separated by a minus to another term, this one. So between these two terms, this is what is common. 2 to the exponent of x and 2. 2 to the exponent of x and 2. Those two are common. So meaning to say, we can factor this as, let's write it this way, 2 times 2 to the exponent of x. That is the common part. This one and this one. So if we remove it from the first term, what are we going to remain with? We remain with a 3. Minus, we remove these 2 times 2 to the exponent of x. What are you going to remain with? We remain with 2 to the exponent of x. So we are going to remain with 1 of the 2 to the exponent of x here, because there are 2. So we factor out 1. So that was the common term for the numerator. The denominator, we do the same thing. What is common? The only common term that we have is the 2 to the exponent of x, as we can see. In terms of the numbers, we do not have any number which is common. It's just this one. The 2 to the exponent of this one. It's the only part which is common, this one, and also here. So you can use this one, but don't use 2, just use 1 there. So that is the common part. So we can factor out that. So factoring out 2 to the exponent of x, what are we going to have from there? If we factor out 2 to the exponent of x from the denominator, in the first part, we are going to remain with a 3. Minus, we are going to have 2 to the exponent of x, which is not affected at the end, this one. So this is what we have. And remember, a bracket simply means there's a it's a multiplication there. So it gives us the power to cancel brackets which are the same, terms which are the same. As long as they're the same, they can be brackets, they can be terms. So when I'm talking of the brackets, I'm talking of this bracket and this bracket, 3 minus 2 to the exponent of x. It's the same. The terms, 2 to the exponent of x, 2 to the exponent of x can cancel, meaning to say we are only going to remain with a 2 in the numerator, and in the denominator, that is just a 1. So 2 over 1 is same as what? Is same as 2, guys. So this is what you're going to have at the end. 2 over 1, which is a 2. So the simplification can be done in different ways. This simplification could have been done in different ways. So it's also understanding as you are simplifying the best way of your understanding, and also not forgetting what you have been doing in class. Maybe there's a method which is easier. You can also use that one. On 2.2, this time it's an equation. Solve for x, all right? 2.22, 2.21. Okay, let's start with first one. 2.21. We are given 5x to the exponent of 2 over 5 equal to 20. That's an exponential equation that we have under exponents. All right, getting rid of this, we can see there's a product. So the 5 is not even affected there. So let's just remove this. Reduce by 5, divide by 5 both sides. Since 5 is not affected with this on this term. So we'll remain with x to the exponent of 2 over 5 equal to what? 20 divided by 5, that is going to give us a 4. In our exponents, working with equations, when the exponent is given there on x, remember what you need is to find x, or to have x, the value of x. So the question is, what is affecting that x? It is the exponent. So how do we get rid of the exponent? We find its reciprocal, x to the exponent of a over b, if it is equal to, let's say, a number like this. Maybe whatever that we have, maybe it is equal to whatever that it is equal to. And you want to find x. You simply find its reciprocal of this fraction, a over b. What is the reciprocal? The inverse. You just interchange. It will be b over a. B over a. Raise it also to this exponent, b over a. The reciprocal. Just interchange that fraction. A over b, it changes to b over a. So what is the reciprocal of 2 over 5? You just have to interchange 5 over 2, the reciprocal. So you raise to the exponent of the reciprocal of the exponent, which is 5 over 2. But remember, it's an equation. Whatever that has been done on the left-hand side must also be done on the right-hand side. So you're supposed to raise also this 4 to the exponent of 5 over 2. Thus, we haven't changed anything. Our equation still remains as it was before. Nothing has changed. If it is like this, because if we remove this, we are also removing it here. You see, we had the original equation. Whatever that you do on the left-hand side must be done on the right-hand side. So you use the reciprocal when given an exponent. So how can we simplify to obtain x? Remember, exponent multiplies. So it's 2 over 5 times 5 over 2. Guys, that's a straight 1 that you get there. So this is x to the exponent of 1 equal to what? Can we simplify the 4 to its simplest form? In the base of 2, we know that's 2 to the exponent of a 2. 4 is same as 2 to the exponent of 2. But look, there's an exponent which is already there, 5 over 2. Do not forget that. So it's now 2 to the exponent of 2. We just changed a 4, this one. We just changed this 4 into a number raised to a certain exponent. Nothing has changed there. It is just rewriting. Why doing this? So that we can simply multiply the exponents. Remember our law, exponent to exponent, we can multiply. So it will be 2 times 5 over 2, which will simply give us what? A 5. So meaning to say, x raised to the exponent of 1, which is x, is equal to 2 to the exponent of a 5. As we saw that when we multiply this, the 2 and the 2 is going to cancel. This is 2 over 1. We can just use a calculator there. What is 2 to the exponent of 5? 2 times 2 times 5 times. 2 is multiplying itself 5 times. You are going to obtain a 32 from there. Or you can simply use your calculator from there. You can simply use your calculator. That's our x, which we can test and see that if we substitute that 32 here, if we substitute that 32 on the left-hand side, 5 times 32 to the exponent of 2 over 5, use your calculator there. You are going to get a straight 20. That is to show you that truly you solved this properly, the value of x. So whenever you're given an exponent, even if it is a negative, x to the exponent of minus 3, it is equal to maybe a certain number, which is 2. They want you to find the value of x. Just look for the reciprocal of minus 3, because that's the x like this, which means the same as minus 3 over 1. So as we are looking over 1, so therefore its reciprocal now will be what? If you are to work from there, it will be 1 over this. So it will be 1 over minus 3. So just like that. It's a whole number, this one that we have. So its reciprocal is simply 1 over that. 1 over what you see. So it's 1 over minus 3. Also here, to the exponent of 1 over minus 3. You see, just like that. So you can simplify. So whatever that you're given, what is important is the exponent. X to the exponent of 2 is equal to what? What is that we have there? A number which is 2. What is its exponent? 1 over 2. The reciprocal, 1 over 2 also. So depending with whatever that you're given there. All right. Anyways, guys, you just have to revise, work out as many questions as you can. Another equation, it was given on 2.22, which is again to solve for x in this equation. But looking into this, we can see that there is 12, there is 3. The bases, the numbers that we have there on the bases are actually different. They're actually different. So what can we do? All right. We understand, guys, that numbers can be separated. This type of a question is a tricky question because you need to know a certain laws. So I'm just going to try to explain in a way that we can all understand. If the base was the same here, let's say we had a base of 3. It was going to be easier because we have the same base. Let's say it was 3 to the exponent of x. We're simply going to add the exponents and try to figure out if this 648 can be written in the base of 3. But this time is totally different because the bases are different. So let's try to separate our numbers here. Okay? 12, let's leave it like that because it's in the base of what? It's in the base of x. So it means 12 to the exponent of x times, we separate this 3 to the exponent of x. And this one, remember, it can be separated as 3 to the exponent of x times 3 to the exponent of a 1, of which we know, guys, 3 to the exponent of a 1 is same as what? It is just same as 3. We have separated this 3 to the exponent of x plus 1. This is equal to what? 648. As we have separated this, the 3 means now that it's no longer useful because we do not have x on these 3. It is just a normal number where we do not have x. So let's remove it. Divide by that 3. Because it's under a multiplication. We can simply divide by that 3. So we are remaining with the product of these two. 12 to the exponent of x times 3 to the exponent of x, which is equal to, divide these guys. It was going to give you 216. So at this stage, at least we can figure out something. Yes, the bases, they are different. The bases are different, but the exponents are the same. So is there a law which connects these two? That's the question. Is there a law which connects these two? Yes, let's go back to our laws. Remember when we, from our laws of exponents when working, let's say we are given a, okay, let's just use the x that we are used to. Or let's just use a and b raised to the exponent of x like this. where was this actually taken from? It was taken from a raised to the exponent of x, b also raised to the exponent of x. This is where it was taken from. Remember this. They are two different, but the exponent is the same. So each term will be separated. So if we look into this question, we are at the expanded part where already it has been expanded like this. But before, how was it written? It was given as a times b to the exponent of x, meaning to say 12 and 3 can be multiplied together, 12 times 3, with the same exponent of x, like this. They can be multiplied together to give us a single, because these bases are different. We cannot work with the 12 and x, then there's a 260. There's no way we can see that, okay, so there the common base is going to be this one. So the only way was to combine these so that we have got the same base. X is the same exponent. The moment we multiply this, 12 times 3, we are going to obtain what? 36 raised to the exponent of x. And this is equal to 216. So the same base concept now can be used, because that is the major part that we had to combine these two, so that these can be related with the same base. Yeah, it was difficult because there's a base of 12, there's a base of 3. How can we write this 216? How can we convert that to be written in any of these two bases? It was difficult. But having two terms, two numbers, they can be related, not 3 like what we had here. So that's why we had to combine these two numbers. We had to combine from this law, remaining with the two terms, one on the left and another one on the right side. Which base is it that we can relate these two numbers, 216 and 36? Which base is it? All right, if you are used to base of 6, you'll see that 36 is just 6 squared, 6 times 6. So that's 6 to the exponent of 2x, because already there was x there. 216 also can be written in the base of 6 to the exponent of 3. So understand also your bases, because there, in order for you to choose the base, you are supposed to be having an understanding of the bases, so that you won't waste your time trying to use the base of 2. It fails. You try the base of 3, the base of 4, the base of 5. Be used to the base so that you know, okay, this is just base of 6. At least you can just try on your calculator what is 6 to the exponent of 1, 6 to the exponent of 2, what is equivalent to the numbers that you're given. 6 squared, 36. 6 to the exponent of 3, 216. The bases are the same. Therefore, exponents must be equal. So by default, we can say that 2x must be equal to what? 2x must be equal to 3. And if 2x is equal to 3, what about the value of x? We can simply solve this equation by dividing by 2 both sides, since that's a product. So our x is going to be 3 over 2, or you can have it as a fraction, 1.5. You can have it as a decimal, 1,5, depending with the way that you're going to have your final answer at the end. But that is 3 over 2. So these are some of the typical questions, guys. As you can see, we need to revise, guys, as many questions as you can, because it's exam. They try by all means. So the exercise to do as many questions from question papers, so that you can see, figure out how do they ask these questions, and try by all means to understand the mind of the examiner. By understanding the mind of the examiner, then you are able to answer as many questions as you can, because you know that this is just a repetition. These questions are just a repetition. They just repeat only different ways of writing, but you see that it's just a repetition throughout. So for you to see that, it is because you are revising as many questions as you can. But without that, every question will be like, I haven't seen this question, I haven't seen this question, I haven't seen this question. It is because of not doing enough question papers. So let's just try as many question papers as we can till we meet again.